Hi, I'm Vincenzo Coya, and welcome to Stat 545, the video series designed to help you write a clean and modern data analysis. Up until now, we've acquainted you with a powerful workflow for doing a data analysis, but now we're actually ready to go ahead and do the data analysis. A big part of data analysis lies in modifying your data. You'll need to calculate new things, add new columns, change some entries, you name it. But to do this, step away from the spreadsheet. Why? Because you'll be hard-pressed to repeat those modifications when you have to rerun your analysis from scratch. And yes, you will probably need to rerun your analysis from scratch. And even if you don't, I don't know about you, but I don't trust that I'll do things right the first time around, and I don't feel like digging through a spreadsheet to figure out if everything's okay. Instead, there's a powerful R package called dplyr that's up for the job of data manipulation. With dplyr, you can achieve the most common data manipulation tasks by using a sequence of simple actions. But don't just load dplyr on its own, because it's actually part of a larger ecosystem of R packages called the tidyverse, which works so much better when loaded together. The tidyverse really does take R to the next level, and we'll be exploring it throughout this video series. So when you go to start your data analysis, instead of just loading dplyr, go ahead and load the tidyverse like you would any other R package. And when you do, we have 4 practices that'll help you get started with data wrangling with dplyr. The first practice is to represent your data in R as Tibbles. Now, a Tibble is basically just a table of data whose columns are named. And if you're familiar with data frames in R, a Tibble is basically just a modern version of a data frame. Now, to modify a Tibble, we break the task down into smaller steps, each step being accomplished by a dplyr function. These dplyr functions always take an entire Tibble as an input and always return an entire Tibble as an output. The only difference between the two being that the output Tibble will have the changes that you requested through the dplyr function. As for loading your data into R, that's a topic for another episode, but here's a hint. You can use the read_CSV function. You can also make Tibbles manually in R using the Tibble function, specify each table entry by hand using the Tibble function, or convert a data frame into a Tibble using the as_Tibble function. The second practice is to subset your Tibble using the select and filter functions. With the select function, you're able to choose which columns you want to keep in your Tibble. Just put your Tibble as the first argument, and then specify the names of the columns you want to keep. You can even specify what you don't want to keep by putting a minus sign in front of the column names. Now, we usually like to reserve columns for holding variables, like penguin species, flipper length, and body mass. So selecting columns by their names is a practical way of choosing which variables you want to keep in the dataset. With the filter function, on the other hand, you can specify which rows you want to keep in the Tibble. Now, this isn't as straightforward as the select function, because we usually want more flexibility than just filtering rows by their name. Not only might you not have names for your rows, but we like to reserve rows as holding measurements on a single individual, in this case, single penguins. We probably wouldn't want to filter out penguins by the names we give them. It would probably make more sense to filter them out by their records, like all Gentoo penguins, or all Gentoo penguins with small flippers. In general, to use the filter function, just specify a condition that a row must satisfy in order for it to stay in the Tibble. To learn more about specifying conditions, take a look at logical operators in R. The third practice is to select many columns using the help of tidyselect. Now, even though it makes sense to select columns by their name, sometimes we just have too many names to list out. To help out in this situation, use tidyselect helper functions to select common columns. Functions like starts with, ends with, and contains. I gotta admit, when I first heard about tidyselect, I thought it was a gimmicky convenience that wasn't really needed. But as it turns out, it's more than just handy, it actually makes for robust code. Say you're selecting columns that start with the word assignment. And that picks up assignment 1 and assignment 2. That means if you were to add an assignment 3 in the future, your code will still pick that up. And plus, the tidyselect helpers show up in more places than just the select function, as we'll see throughout this video series. The fourth practice is to form a chain using the pipe operator. As I said earlier, modifying your data will involve multiple steps. Even using 2 steps like select and filter can start to become messy. Putting it all on one line is hard to read, and assigning a new tibble for each operation isn't the friendliest either. Instead, use the pipe operator. It takes the output of the operation before it and puts that into the next function. Doing this makes your analysis much more readable. In this example, I can read this code as first taking my data and selecting some columns, and then filtering some rows. But do yourself a favor and don't go making a huge chain with the pipe operator. It just makes things harder to deal with when things go wrong, and it inevitably will. So those are 4 practices to help you get started with dplyr for data manipulation. Represent your data in R as Tibbles, subset your data using select and filter, select many columns with the help of tidyselect, and form a chain of steps using the pipe operator. I hope you enjoyed today's episode. Join us next class where we discuss plotting with ggplot2. Don't forget to subscribe to this channel so that you can stay up to date with more data analysis goodies.